Hello, this is Callan Bentley. Welcome back for another Smart Figure. In this video, we're going to take a look at the phenomenon of sheeting and discover how it forms and what its consequences are. So let's begin our discussion by taking a look at the iconic landmark called Half Dome. This is in Yosemite National Park in California. Basically, there's two things at work here. First off, let's note the scale. There are people here climbing a ladder to give us a sense of scale. Part of Half Dome, basically everything to the right of that line, has been removed by glacial action, and we'll talk about that perhaps in the glacier chapter. However, what we want to focus on right now is this sort of onion skin looking feature here, these flakes that seem to be coming off, and they're all parallel to the sides of this dome, or half a dome. So what's going on here is that Half Dome is made out of granite. Granite, as you know, is an intrusive igneous rock and forms deep underground, so it forms under confining pressure. So there's basically pressure on that magma chamber at the time it intrudes into the crust, and then it crystallizes into igneous rock, so crystals form and it becomes one of these big blobs of igneous rock that we call a pluton. Now, if later on that pluton is brought up to the surface of the Earth, the pressure on it has been released. And as a result of that pressure being released, it actually expands outwards in all directions. So the relief of the pressure basically causes it to increase in volume very slightly. And that increase in volume is actually greater than the strength of the rock. And so the rock tends to break in a series of fractures that are basically perpendicular to the expansion direction. So if it's expanding in all directions, you end up getting this onion skin-like pattern of flakiness on the outside of that pluton. So when you go to Yosemite National Park, you're going to see this just about everywhere you look. You might hike up to view a waterfall, but look beyond the waterfall and you can see all these parallel fractures of rock. These are examples of sheeting. All right, let's quiz you real quick. Which of these two types of rock, intrusive igneous rocks or extrusive igneous rocks, are going to be most likely to experience sheeting when they're exposed at the surface? Hopefully you said the intrusive igneous rocks because they form deep underground under confining pressure. The extrusive igneous rocks wouldn't work because they form at the Earth's surface, so there's no reason for them to expand when they're exposed at the Earth's surface. It's only the intrusive igneous rocks that basically form at depth and then will expand when they're brought to the surface. So an example of an intrusive igneous rock would be a granite. Thank you very much for your attention. This has been another Smart Figure.